Hello, my name is Connor and today I'm going to talk to you about attitude, determination and control systems. Attitude Determination and Control Systems, or ADCS, is a very important system on board all spacecraft today. The ADCS is responsible for determining a spacecraft's attitude and implementing forms of control to maintain or change this attitude. So what is attitude? Well, attitude is the orientation of a spacecraft in three-dimensional space. It is essentially the direction that the spacecraft is pointed. The ADCS is responsible for determining the attitude, which is done by using a variety of sensors that measure parameters such as acceleration, rotational torque, and magnetic field strength to determine the current attitude of the spacecraft. The ADCS is also responsible for controlling the attitude. This is done using a variety of actuators, such as rocket thrusters, solar sails, momentum wheels, or magnetorquers that change or maintain the attitude of the spacecraft. So, during my honours thesis for my bachelor degree, I worked with two other engineering students and we tested or validated the ADCS of a cube satellite being developed at the University of Adelaide. Together, the three of us designed and built a ADCS simulator to try and replicate some of the conditions that the spacecraft or the CubeSat would experience up in low Earth orbit. We did this with a Helmholtz cage, a spherical air bearing and a weighted platform to simulate several aspects of the space environment that we wanted to test for our system. Now this is the Helmholtz cage, which makes up one part of the test simulator. The Helmholtz cage is designed to generate a three-dimensional magnetic field which is supposed to simulate the magnetic field environment up in low Earth orbit, where the CubeSat will be operating in. Now the Helmholtz cage we designed with low-cost materials in mind and to make it as simple as possible. So to do that we used PVC plumbing pipe and a wrapped Ethernet cable around. Both these items were relatively cheap and accessible for us. We also used local wood from the hardware store and to make the frame which holds the Helmholtz cage together. Now the Helmholtz cage is just one aspect of our test simulator, but due to the basic materials we use, so basic piping, basic copper wire, basic wood, almost anyone with these materials can make their own Helmholtz cage, and even further can make their own attitude determination and control system simulator if they wanted to test small satellites for their high school, for the university. This thing is affordable and achievable.